presentation only this time, no hands-on stuff. I promised you that we talk about publishing real-time data notifications into MeteoGate. So you're all familiar that these are the components that we have available that we're working with. And this time, I'm going to talk about the global broker, the data access API, and the local broker. So let's line up the components. Let's just remind you that there are technical regulation in WMO. There's the red book, which is the manual, and then the guide. The links are here. And there's also a cookbook that we're adding useful recipes to as we figure out things that are valuable. So, as you all know, WIS2 uses real-time notifications published via the MQTT protocol to tell users about new data. The WIS2 notifications must follow the specification. There is a link in here. By the way, we do all of our documentation in GitHub, so sometimes you'll see links to the GitHub. The official one is the red book, which is like a PDF published on the library. It's the same content. It's just like an HTML link into the thing we publish on GitHub. So don't get worried about that. It should say stable in the URL. So WIS2 notifications are GeoJSON, which is useful because it means you can display the notifications on a map using a GeoJSON viewer. So that's really cool. So first of all, we publish a notification message to your local broker. That local broker is part of your data supply capability. And do you use the right password? Yes, you do. Okay, side joke. So then the global broker subscribes to the local broker and it validates received messages and republishes them. We're familiar with this because this is the way the metadata works, right? And then the data consumer subscribes to the global broker and they receive notifications about the availability of new data, WNN WIS notification message. It's just this JSON file. And then the data consumer downloads data from your data supply capability, i.e. the WIS2 node, via the link in the notification message. So that's the way it works. You publish your notification and you publish your data on a HTTP endpoint. The global broker grabs your message. The data consumer is subscribing to the global broker, so they get the message, then they look in the message for the download link and download your data. All right? Simples, as we say.
Could mention that in ESO, we actually send the data in the message.
Yes.
Yeah. So you could actually collect the data from ESO directly and without picking up the file.
Okay, so that's a really useful thing. You can embed the data in the message. You should still publish the message to an HTTP endpoint as well. The maximum message size is 8 kilobytes.
It is before.
The maximum size of embedded data is 4.
Okay.
Right? Because there's some other stuff that goes around. And let me just say, that's 4 kilobytes after you've base64 encoded it. Okay? So
what was it? 8 is?
You said 8 and 4. So the total message size can be 8 kilobytes. The base64 encoded embedded data, no more than 4. Right? I think I read that in the spec just recently, so the expression. So, as we talked about before, and Stuart, you gave us some really useful insights back on Wednesday about the topic hierarchy. We use the topic hierarchy to make sure that when Geosphere, when you publish your stuff, and Finland, when you publish your stuff, and Norway, when you publish your stuff, it doesn't all get mashed up, right? We all each publish to different things. So here we can see the topic hierarchy. So we start with channel, origin, and cache, and I will talk more about cache in just a moment. A is the version, because it's always good to have a way that you can deal with breaking changes. Next, we've got WIS2, because that's our system. And I would say that all of this infrastructure that we're building, if you want to publish real-time notifications using the same infrastructure as you built for Wiz2, you can use the same stuff, just publish to, I don't know, name a system that you've got, like KNMI, they might have KNMI data platform. They could use, instead of level 3 being system Wiz2, they could say KNMI or whatever, and then you can use that. You can use all the same infrastructure, but the Wiz2 global services, they won't read the messages, they won't see the messages, because the global brokers only subscribe to Origin and Cache, Wiz2, and then what is it, HashMark, right? So you can reuse everything. The center ID, we've talked about at length, so I'm not going to go there. I have put a link in here to the official current list. Notification type is data or metadata. I'm going to talk about data today. The data policy is core or recommended. We have talked about that previously. And then the Earth system disciplines. So these are based on the set which are defined in the WMO Unified Data Policy. What should we do next? Okay, now each one of the Earth system disciplines is then further subdivided into subdiscipline and sub-subdiscipline. And Stuart, you gave us some really useful discussion earlier in the workshop about how these level 9 ones, they don't quite work for surface-based observations. And I think that we've got an ongoing thread now with the WMO team to get these fixed, which is great. Remember that each one of these is then broken down into subdisciplines. Here we have advisories and warnings, which you guys would use for geosphere. And then we've got aviation products, we've got prediction, future, space-based observations, which is basically anything on a satellite platform, and surface-based observations, which is anything that's measured on the surface or a platform that started on the surface and then was floated up on a balloon. So it might be an upper air observation, but if it's a wind profiler, the thing is on the ground. If it was on a radio sond, it used to be on the ground and it got floated up. They're all called surface-based observations. If you don't like it, tough. That's just the way it is.
And that also goes for radar.
Yeah. Radars generally are on the ground.
Yeah.
Or they started on the ground at some point. Anyway, right, okay. Experimental, we talked about previously. Sometimes you're going to want to try out publishing new data and new topics and stuff. Experimental is your play space. So you can add further level 9 terms on experimental, and the global brokers will say that's okay. If you don't use an official topic, the global brokers will not republish your message. So nothing will happen. I won't go into any more details on that. So I'm going to mention global cache. WMO, the Wiz2 infrastructure is designed to support provision of data from 190 countries to a global audience. Some of those countries have quite small scale capability, and their network connections are intermittent and so on. So part of the Wiz2 infrastructure is that we pick up all of the core data which is published and copy it as files into 5 or 6 globally distributed caches, which are highly available. That's why, if you remember, we had the first level in the topic hierarchy. Let me just go back here. Come on. There. First level in the topic hierarchy was origin or cache. The intention is that we get our data consumers down here to subscribe to cache, which means that we don't overload like Somalia or Vanuatu or whatever. And so all the traffic goes to the caches rather than the origin endpoints. Here in Europe, I'm expecting us all to be able to handle the traffic, okay? But in other places, we do encourage people to go to cache first. So let me just remind us, core data is necessary for provision of services and support of protection of life and property. well-being of all nations, recommended data is basically anything else that's interesting. Let me not go into that. Okay, so how does it work? First of all, the global cache subscribes to the local broker. The global cache receives notification messages, downloads the data objects into the cache. They publish new notification messages saying, hey, I've got data in my cache. Then the global broker is subscribing to the global cache, and they get the notifications about newly cached data. And the global broker republishes those on the cache topic. And then, like I said, the data consumers generally subscribe to the cache topic, and then they get a notification about the data being available from one or more of the caches. So each global cache will publish its own notification messages. When you're working natively with WIS2, you need to be able to deduplicate between messages that say the same data item. You could receive a message multiple times. You just got to deal with the deduplication. There's a whole bunch of recipes in the cookbook to help you do that. Does that all make sense, everybody?
How does it handle, so you download data in cache, does it transform the URLs in the new messages to be a URL to the cache?
Yes.
Yeah.
Yeah. So
which relations are transformed? Because some of them are probably not.
Only the canonical. Well, what happens is only the canonical one. So the canonical one is the default one that you should actually use if you're wanting to get data from a file. There's also the update one. But anyway, I can talk to you after that offline. But generally speaking, when the global cache publishes a new message, it's exactly the same as the origin message, except the addresses are different. So same topic, same everything else, except it says cache on the front.
I know you said this, but the cache will only contain core data.
That is correct.
Yeah.
So some publishers, like our friends at ESMW, publish terabytes of data a day. And given that there are half a dozen global caches around the world, and some of them pay for their own egress costs, it's not really fair for them to have to serve everybody else's data. So there is a mechanism for a data publisher to, in the message, say cache equals false, which is like, don't cache me. I am quite happy to serve the content myself. What will happen then is the global cache, when it republishes its message, it'll still publish it on the cache topic, but it won't update the URLs. What that means is that my data consumer, if they're subscribed on cache, they don't have to care whether or not a particular thing is cached or not. They'll get all the messages published by the caches. Most of them will point to data in the cache itself, and some of them might point directly to ESMWF or Met Office or whatever. So it's, we're working it out.
Yeah, that makes sense.
Also, I don't know if you mentioned it, but since there are multiple global caches, and everyone publishes the message, so if you simply test to listen, you end up downloading the same thing multiple times.
Yeah. So as a data consumer, you need to look at the data ID in the message and figure out if you've downloaded that one already. So there's some deduplicate. I mean, you could just read all the messages and download everything. It would be wasteful. So as a data consumer, you need a tool that allows you to deal with the duplication of messages, right? And WIS2 box can also work as a client that has the deduplication mechanisms embedded inside. David's colleague, Remy Giraud, has written a whole bunch of Node-RED stuff, which deals with deduplication and stuff. So, if those things are interesting to people, we can share. But check out the cookbook. There's information in that. Okay. So, yeah, given you kind of were one step ahead on the presentation. I clicked anyway, given that there are multiple global caches. So Like I said, FWIW for what it's worth. We don't worry much about that in MeteoGate because we're kind of expecting to be accessing data services and a lot of our data is going to be recommended. Just be aware that data is going to be picked up and shoved around on the global caches as well. It is what it is, right? Because in WO, core data is free and unrestricted and available to everybody in the world. What do we have? So we've learned how the notification messages flow around. I'm going to take an example to look at. This is a fictional example providing advertising the availability of a new data from a WIGOS station in Rotterdam. And it's part of the KNOI's current 10-minute observation data set. So bear in mind this is fictional, so some of it might not work. This is an example which I hacked together previously, and so I'm just reusing it for this. As you can see, I've assumed that none of us can actually read the small writing, so I've made it big. So first of all, notification. Every message has to have a unique identifier, so you use a GUID. The PyWiz PubSub tool that we were using for metadata publication automatically inserts a GUID for the message. You remember I said previously that there were also multiple global brokers. You should subscribe to more than one global broker because occasionally they go offline. So for example, the French one was offline Monday evening for a little bit. So if you are only subscribing to one global broker, then you could miss messages. So you might want to subscribe to the American one and the French one, or I forget which other countries there are. There's China, there's Saudi, there's Brazil, so on and so forth. So globally distributed. You should subscribe to at least 2, and then you will receive messages with the same ID from each global broker. All right. Again, you need to figure out how to deduplicate between the 2. So including the geometry for the data item is good practice, and it helps data consumers figure out whether this particular piece of data is relevant to them. This is particularly relevant for observation data sets where you might have this station or that station or this station. It helps people see where the data is valid for. The data ID, this data ID, so the same piece of data might be served by a global cache or it might be served by your origin. That's the thing that you can use to uniquely identify the data rather than the message. There is no structure in the manual. It just needs to be unique. Most people are using the topic structure and then appending like a local file name on the end. That seems to be the most popular way that people are ensuring uniqueness. So here you can see the topic structure, which is the NL, KMI, I should say NMC, sorry, my bad. That's the center ID and the data recommended where the surface-based observations, blah, 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 blah.
Can you share the presentation?
Yes. In fact, all the presentations will be made available on the SharePoint afterwards, but I'm quite happy to send it to folks early if you want, right?
Thank you. Yes.
See me afterwards. Yeah. So date time, this is the date time associated with the data. So like for an observation, this is when the observation was taken. And again, this is really useful for the user to determine if this is data they're interested in. Pub time is when the message was sent. Now, sometimes, for those who know GTS stuff, you might have a correction, basically an update to data that was wrong. In this case, the pub time needs to be later in the correction message. That's kind of obvious. But we also use a...
Unless that they don't hear anything from that.
Oh. Well, I'm unmuted. Does anybody else hear anything online?
Yes, we hear you.
Okay, Anders, it looks like it's just you. Sorry. Oh, but he can't hear me, so can somebody type in? Okay. And also, could you type in that we're recording the session so that Anders could catch up a bit later? That'd be helpful.
I'm not familiar.
I'll do it.
Thank you, Willie. So yes, so when we do a correction or an update to the data, we use a rel equals update in the link block. The discovery metadata for the data set must exist before you start publishing real-time notifications. The global brokers will discard messages that don't have metadata associated with them. On top of that, it's also really useful for data consumers to be able to use the URN for the metadata, and they can search for that either in a search engine or in a global discovery catalog, and then they'll find out the license, the terms and conditions, and much more detail about it, like you might have links to related documentation. So it's really useful in the message to put the metadata ID. Inside a GeoJSON record, in the properties block, you can put whatever things you like, right? And so what, in this particular record, we use a property called WIGOS station identifier that coincidentally has the WIGOS station identifier, which is kind of useful. So this is okay, this is good stuff. But really what this shows is you can do client-side filtering. So let's imagine that the KNMI's data set, it's got a couple of hundred stations in the data set. You're receiving notifications all the time, blah, 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 and you might only be interested in data for Rotterdam and Antwerp. You can filter, you can look at the notification messages coming in and just say, I'm only interested in ones with WIGOS ID 06344, whatever the other one is. Client-side filtering. There is a recipe in the cookbook, which is linked here, about client-side filtering. In your metadata, the discovery metadata record, you can include the information for people about which properties you use in notification messages to help people know what they can filter on. We also, I'm new to it, and then it's going to be all right. We also shouldn't assume the data consumers know what they're supposed to do with the data. Yes, they could all look up the metadata, the discovery metadata record that's got the license and the rights in it, but I would imagine that not everybody will. So I think that there's no harm in including the rights statement and the license link in the notification message itself. It's just a few bytes. As far as I'm concerned, this is reminding people at the point of use that what they're supposed to do or not. So here's the crucial part, the link that points to the data. All the links follow a similar type. The rel is the link relationship type, and the rel equals canonical is always the default one to look at. Other link types include update and license, which we talked about earlier, and then item and station, they're coming next. There is an incomplete set of link types provided in with the metadata specification. You can take a look at that. Type provides the media type or MIME type of the resource. Length enables a simple integrity check. There is also an integrity check block in the notification message. I'm not going to go into that because we haven't got time, but check out the spec. href provides the URL for the resource, and in this case, it's an observation for the Hague encoded in buffer. For core data, it's the URL in the canonical link that global caches download from. And that for core data, the canonical link must be directly resolvable. So that means no access controls unless you're using an IP whitelist, so that global services can pick it up. See me afterwards if you want to know more about that. And you can't use URL templates. Like, you can't assume that somebody's going to put some extra values into it to make it work. See the Wiz Cookbook for more information on how to embed data within the message, which is what you were talking about earlier, Vega. Okay. KNMI, in this case, they also provide EDR API, here you can see, because it requires authorization with this API, we have I've included the security block. So here we can say it is, this follows for open API security schemes. So those are the ones you can choose from. So this is just a name, type is a name. Name is a little bit awkward. The name is actually the name of the header. Authorization is the header. And this is saying, where do I put my key? And it goes in the header. And then there is a description that provides some useful stuff, which is like, please go and register here.
You see Anders'
No, I can't read that. Your route is applied but does not work as an absolute. Presumably, Anders, that was. Can somebody ask if that's to do with the presentation or some work you're doing separately? Anders' question looks like it was about the tutorial previously. Just in the interest of getting to the end of this, we can also use links to point to additional useful information. So in this case, we can say rel equals station and point to the OSCAR database. And that is all I have to tell you about notification messages, which hopefully provides some examples of what you might want to include in those messages. All right. Any questions? Okay, thank you very much for being with us. Everything will be shared, so you'll see those resources afterwards.
Question.
Please go ahead, Peter.
Okay, so what's the minimum requirements? Like, to have, I guess, a valid notification message?
I check out the spec. There's a JSON schema. It's probably easier for you to read JSON schema than a text document, right? But there are
the WMCP2 thing.
So that's the metadata one. So there are links in here, but it would be the repository WMO-IM for the organization, and then it's Wiz2 dash notification dash message. All right. Any other questions? You can also use PyWiz PubSub, that utility, to validate the messages. So if you're trying to try some stuff out, you can validate it locally without having to try and publish it anywhere. All right. Any more questions? None. Okay. I will hand over to you.
Yeah.
Now we're going a bit back to ESO and to the Oasis software. So Armin will show us how it is possible to set up the system at NMS and to run it locally.
Yes. So figured out what was wrong with the MQTT from the MeteoGate yesterday, so we can do that first if you would like. So let's share. So I'll post the username and password in the chat. And I will also post the connection link.
Okay, so just to recap, the aim of this session is if you want to deploy the Oasis software yourself, we're going to learn how. All right?
Yes. Okay. So just save it from the chat. You'll have it later. You can test it after the session, see if you can actually get in or not. There might be some white list on, but I'll turn it off if it's still set up. Okay. I made a pretty drawing somewhere, but it's not Oasis. You cannot see that for me. But you should. I'm sharing.
Seems that that's my cursor. It seems that my video meeting is going at least.
It's a complete thing. I'm pretty sure I no? Do you want to share my no. No, it does not.
Is it something that you can share with me and I can share it?
Good question. Why is it being like this?
I don't know.
You does it want to? Okay. I don't know why I don't. I'll just do the good old reboot then.
So 2-minute break?
Yeah, I guess. Sorry. This was now.
It's
Still nothing?
it's anyone else on the meeting? You don't see his presentation either. Not me. You see he's trying to share something. You don't see it either.
Is the online people do see it?
Okay,
You can see it.
I can see it.
Online.
so it's something wrong with you? Ah, that figures.
What's wrong with it?
Huh?
Sure, it's okay.
Okay, so you have to rejoin the meeting, I guess.
Hmm?
You have to rejoin the meeting, I guess.
Okay.
Did you hear us online again? No?
I have to switch.
That's good.
There. Yeah.
Okay.
So,
Oh,
No.
That's not how I implemented my minutes. I'll just try and change the color so it's a bit better contrast for everyone. Okay, good. Okay. So I quickly just drew up how all the components you need to host yourself if you want to try and run ISO locally at your institute. So the boxes in green are the consumer-facing services you need to host yourself, and the light blue ones are the backend services that also need to host yourself. This PostGIS database can be whatever PostGIS database you want. You can host it however you want. We think KNMI has hosted it in their AWS database. I don't know much about AWS, but they manage the database. We just spin it up using .compose, using an image from Docker Hub. And the store, ingest, and DDR API is the services that's written by us. So this back store is a Golang server hosting the gRPC, and it both handles both ingest to the database and requests from the DDR API. This tiny migration box is just a database migration script that runs when you start a database. For example, when you roll to a new version, it handles the moving of tables, so nothing breaks.
since of Islam, doesn't see the presentation in heaven.
Well, I think you have to rejoin the meeting.
Try to rejoin the meeting.
Same as we did, yeah.
Yeah, I see it at the top corner.
All the services, this is pink line connected to it. Export Prometheus metrics, so it's ready to just hook up your monitoring. So, but that's optional, of course. It should just work, but you never know, right? Okay. So I have created a repository with the Docker Compose definition for if I can usually have a very large monitor for this, so it's a lot easier to find the correct tab. Here we go. So put that in the chat as well. Chat. Yes, so I have here. Is that readable for everyone? Is the contrast a bit low, maybe?
Safe travel.
I can mention that one.
Don't take it personally.
No, they're probably gonna figure out for themselves, I think. If you go to the ESO repository for the Hustle source code, the configuration documentation is in each of the subfolders readme files. But apparently it's for the API. I don't know if there's much to say, but we'll get to it. So there's one for the API, and this data store one is hidden in this data store folder. So here's every configuration option. You enter default values, and the same for the ingest. I hope. Yeah, looks like it. Okay, let's continue. So, just not to get all the services at the same time, I have just made some branches in the repository for each step of setting up the service. So here it's just the backend services. There's 3 of them, and we have used this this version of PostGIS just because it's an ARM image, because we have users on newer Macs, so they need some special treatment. There's nothing.
Does it work with vanilla images as well?
It works with any PostGIS database. It's just using the image that runs on your machine. So this particular image has some quirkiness with how it loads the plugin. So it restarts. So we have written our own little script that's also included in the repository for just checking that's alive. Because we use Docker Compose's health checks to make sure services are started before we start running the dependent services. And if you're running in Docker, there's this shared memory size needs to be increased for a database container, or else it will run out of the shared memory, which is by default 64 megs. Just so if you get some strange errors, you know, it can cause some weird issues and crashes. But anyways, it's just set up as a normal database, and this migrate service, which is the first one we've written ourselves. You can pull all the images from our registry on GitHub. If you go to so for some reason the packages for a repository is not listed in the repository itself. You have to go to just look at it now to the owner page and to packages to find the different packages published under this organization. So you can see by which project is published here. Oh, you can't see. I can see right there. And then just have to run each one of these. Yeah. So then we also configure the store with the required configuration options listed in the README.
Did you say that it's not showing under the repository?
You have to go to the. You can go to either the release of in the repository, in the ESO repository, or you have to go to the owning organization and then packages.
No, it's in the ESO repository also.
Yeah, if you go. Oh, is it now? But I don't know if that's for everyone. Anyways, we can assign them there. In the release on the right side of the GitHub. You'll probably use GitHub. Yeah, so read through the configuration options. So you can actually set whatever rolling buffer you want. So this is 24 hours back in time, and then we have also 10 minutes into the future, because for some reason we post observations from the future. It happens. Yeah.
That's what weather forecasting is, right?
Yeah. Well, observations usually has happened already. Yes. So here's this is just set to DB, but that's because of Docker Compose. This is the internal URL lookup for this container. So Docker Compose handle this for us. Yeah, and we have a small check here that also just checks that the DLT service actually is working. points here. Yeah, it's not very exciting. We can just run this and it will just, you don't need to build anything. It will just start and we're running. You probably have some more steps here to download the images, but at this point, it should be working. So if you have Docker Compose on your own machine, you should be able to get this working. So notes, I'm on the backend service branch just because it's to just have a bit fewer services at a time. Because writing the slide would probably just break. We can continue to the.
In the example of Compose test, unnecessary Grafana storage.
Yes, so I just removed Grafana because people usually don't post that in every project they run. Because I used the one we had in our development repository, but there's a lot of extra stuff there. So
is Prometheus required?
Prometheus, well, that's what we export for. But you need Prometheus to harvest up the what are they called? Metrics, yes. To harvest the metrics before Grafana can have a look at them.
Yeah, no,
Yeah.
if you just want to test it, it's Prometheus, if I need it just out from the Compose.
Yes, everything will work. So yeah, the services will still expose metrics, but nothing will scrape them. Yeah. Let's see. So now it looks mostly the same. We have just added more of the API services. So this one's called API is the EDR API, not the ingest service. Yeah, configure the backend storage service and gRPC port. So gRPC by default has a size limit of 4 megabytes for their messages. You're supposed to use streaming if you get large messages, but it doesn't really make sense because we want to just send all observations when you request them. So here we just set, for testing purposes, we just set this to unlimited size and hope we don't run out of memory. But so depending on the service, so in the IoT deployment, where we get the problem of running out of space in the gRPC messages very fast because we have, for example, in the locations endpoint, there's so many locations that we just run out of space. But in non-deployment, when you look at a smaller area for Finland, for example, there's no issue with looking at the locations for Finland. Yes. Yeah, and just look at the readme files, but there are. You can also configure the web server as you want, using the Gunnicorn default arguments.
So, question for audience: is anyone going to try this at home?
Maybe. I actually have a question.
Yeah.
Go ahead.
The thing about the deleting after 24 hours.
Yes.
Can I disable that?
Yes. So I see I'm not very exciting to listen to because I already said this, but here you can. Yes. So in the store, well, I was just going to race through it, and then if you want to, we can try it out if anyone has any, because it's not really exciting looking at the document post, right?
But the database doesn't have partitions, so if that's very.
Yes. So you can host whatever database you want, as long as it supports Postgres. So if you want, just use this to store observation for however long amount of time. You can't guarantee that tables will become too big and slow. But you can set up your own database cluster or whatever you want. In the backend, just configure the connection from the store service. Then the performance will just be we probably have to skip the migrate service because if it breaks or something, then that's unfortunate. But something like timescale DB probably would work fine because it just handles the magic in the backend.
I also don't remember how many exactly values we have. Wow, it's a lot. Couple millions. I don't think it's.
Yeah, that's probably fine, right?
Yeah.
But so observations is a separate table, right? So it heads to the table every time it gets a new row. So if you have many stations for very many years, you probably will get to a large number, but I don't think we run into issues until we get to like a billion rows or so.
Yeah, because we already have an API.
Yeah.
Logical.
Yes. So
It's
in Europe, most people probably have an API, but if you're running some kind of different service, right? So you have a smartphone pressure readings. That could be very handy to spin up some meets the service, just format your output in the correct JSON format.
Yeah,
And then you have
publish those.
No, but you can use them for internal use, right? So you do that for IoT projects as well. So several institutions in Europe now have gotten access to use the NetApp data. That's easily available now in the API.
So I just remove those environmental variables.
Yeah, just set this so low time is it says in there, but it's just how far back in time in seconds will you keep. So
You could use infinite.
you can disable it.
Yeah.
It says in the README. Yeah, the configure options. Yeah. So here I've also configured a simple MQTT service along with ingest. So in this case, we have 2 MQTT brokers just for simplicity, but shouldn't be a problem because you can configure the topic whatever you want, so you can just have them in the same broker if you want. So this just runs an Mosquito MQTT broker and spins them up as.
What's in the configuration?
It's just the configurations in the repo as well, but it's just what port to list for increments.
Oh, yeah. One is for WIS2 and one is what?
That's for our. So we have made two queues in ESO. So one is for WIS2 compliance, and one is formatted a bit more user friendly, so you can actually use the MQTT topics to filter out for the observations you want. You don't have to actually look at any message until you get to the message you want to read.
So the topics would go by station?
By station and then by observed property parameter.
Yeah.
Then you can grab.
Yeah.
So it's supposed to be.
I can show you afterwards.
Yeah, so end users are supposed to connect to that one.
End user is supposed to connect to the MQTT stream, but the WIS2 one there's no need for any users to connect it. That can be done through the global brokers. Yeah. I can show you how the stream looks in a second.
Can I ask?
Yeah.
If I just want to test it, do I have to run the WIS one? Can I leave it out or does it?
So yes, good question. So if you don't configure any WIS2, any MQTT, then it will just skip posting MQTT.
So if I leave out the environment variables?
Yes. So if you don't configure anything,
doesn't try it.
yeah. So that's.
I think you should also to the API put an option saying I don't want this published on WIS2.
Yes, there's a flag in ingest that disables or enables WIS2 publication. Because the plan is to also grab observations back from WIS2. So it'd be nice enough to post an into yes.
Okay.
Yeah.
So we're a little bit time compressed.
Yes.
So we could do 5 more minutes on this if folks have got it. If folks have other questions. Otherwise, for those who haven't got to rush off at lunchtime, I guess that you're around lunchtime.
Yeah, I'm actually leaving after meeting because it's Norway on Friday, so.
Okay.
And the weather's nice, so I'm going to play disco. But
So your email address, if you.
Yes, of course. And this repository is public, so if you have got the repository machine, just download the repository, clone it, I guess is the technical term, and try it out. It should just be to spin it up. So also added this. I haven't tested it, but you can convert Docker Compose definitions to Kubernetes or OpenShift. And you can, so this is just converted from that. So I don't know how well it works, but at least it shows the example of how it should look. There's probably some optimizations to do here. For example, attaching the migrate server to the same spot as the database. That's
Cool. Any other questions that we can wrap up now?
Sorry, it's a very newbie question.
yeah.
You know, in architecture, because it's the first time that I'm working with ISO.
Yeah.
Architecture, this instance of, are you supposed to run it in each NMS or?
No, so the one running in EWC are supposed to handle the normal, or at least for now. Depends on what the EUMETNET decides about funding.
Okay, so.
But for now, we hope it's not. That the instance in EWC is running at least to the end of 2026.
Okay.
So, but we haven't made
2028.
28 now.
Yeah, we
Okay.
just don't know who's going to run it.
Oh, right, okay, so
2028.
DWD is running
We have a
until
plan.
26, but someone else is running after. Yeah, and but KNMI is developing this EDR aggregator that will work perfectly with this service if everyone is running it themselves. So there's options, but for now, the plan is to have you publish, or just give us your data instead of actually running the system yourself.
So, for example, if you had an observation data store that you wanted to, it wasn't part of ISO, and you wanted to publish that through an EDR endpoint, you could deploy this, feed the observations in, correctly formatted in JSON, and it will go to the database, and you have an EDR endpoint to access all that data. So this is like a tool, a utility. You don't need it to feed your data into the ISO system. This is just saying, hey, we've developed some really useful software. Members, take it if you like it.
But it's not designed for you to take it and do all the deployment yourself. It's
You
designed.
could also comply with this too, and MQTT, so
Yeah.
by using this software. So
Yes.
Okay.
So
Any other questions?
we can quickly look at the this is not well, doesn't matter. It's
The
not
EDI
essential.
API builds on the, like the KNMI work, right? With
The
the
profile?
fast API and identity.
Well, it's the same. It uses the banana package. It's actually the same developer. It's written most of the API as it's written the pedantic package.
It's the same developer, so,
Yeah.
so it does use it, right?
Yes, it uses pedantic packages.
Yeah.
Yeah. Or packages for both the EDR and for the coverage JSON. And I think they have made both of those pedantic packages. I don't remember. Yeah.
And open
Yeah,
data,
that's
the same.
OpenRadar data is using the same, most of the same source code. They have converted it to, so we can upload to S3 buckets and share those instead of producing the actual observations. Okay, so here's the topic structure. So we use so it's sorted by country, or it's actually sorted by the data producer name. So thankfully, everyone has done the same format here, so it starts with
This is
country
like their
and then institute.
native.
This is our native topic
Yes.
structure, yes.
Well, native. Yeah.
The one we
Trying to
found
understand,
convenient.
User-friendly field.
So the
It's a
way,
completely optional part in that sense.
yes, but it's very
So-
convenient.
This is optional.
You can use it in-house, you can make it available out of the house, or you can just remove it.
Yes,
It's not part of the, I guess, ingest flow.
not for the WIS2, no. So here so it's sorted by country and then institute publishing the data. And then station ID, and the final topic is the observed property. Then you get to the actual message.
Yeah.
So here you can change this for, if you change the station here with a hashtag and then the duration of sunshine, you will get all the duration of sunshine readings from the nodes posted by KNMI. Yeah. So we don't need to look at any messages to filter out the things you don't want.
And there's definitely a use case for that.
Yes.
A way that people want to interact with the data.
Yes.
And it's a slightly different one for the WIS2 stuff, and that's why you have two feeds.
Yes.
Yeah.
Perfect.
Yeah, and yeah, because we wanted to comply with these two, so it was necessary to have two.
Yeah.
different things.
Cool. So in terms of timing, I'm gonna try and get us to finish at 12:45, which is a little bit earlier than advertised, just because Vigar and me have to go to another meeting at 1 o'clock, and we need a bit of space, right?
Yeah. Maybe some food.
Huh?
And maybe some food.
If there's time for food.
Yeah.
So so we have just over half an hour. And just to check, thank you so much for number one, for sitting while we were late for you. Really interesting to see the software. Take it, play with it, see if you can make it work. Any questions? You're probably on Slack and email and various other things.
Yeah, I can post my email at least in the chat in the meeting, and you can grab it from there.
Cool. Easy peasy. So, any more questions on this topic?
What is the MQTT version for those messages? 5?
I think it's fine now, yeah.
I don't manage to make this MQTT client.
You can't spin it up. I can look at it. It's yeah, in a second.
Yeah, cool. By the way, Mosquito as a MQTT broker doesn't cluster, so
it's simply for local testing. It's very lightweight, and
Yeah.
and run it locally when you're testing out your MQTT is fine, but not recommended for production.
Indeed. So you remember on Monday I went through a bunch of options about how you might build a notification publication day. There are loads of options, from going through from lightweight Mosquito through to Solace or Hive or VernMQ or whatever. So loads of options. Right. So ordinarily